I'll show you now how you can use ADFJobs as a great tool for managing your jobs so that you can create your jobs, your input files locally and submit them to a cluster via the graphical interface. You don't need to worry about it. The only thing that you need for that is to establish an SSH connection via an agent, and that's most involved on Windows systems, so I'll show you how you can do that using the tools, the PuTTY tools that we ship with the ADF package. If you can generate an SSH key pair on a Linux system or a Mac OS system, then the principle is the same. It's just a bit easier than on a Windows system. Okay, so once you've downloaded and installed ADF, in your installation directory in bin PuTTY, you'll find all the tools that you need for this. First, we need to generate an SSH key pair. So we double click on PuTTY generate a new key. You need to move your mouse around a bit for randomness, and then you will have generated a key pair, the public part of which is public, so you can share that with everyone. In this case, you will want to share it with your system administrator, or you can put it yourself on the remote cluster that you want to run your jobs on. The private part, the private key, you of course want to keep private, and that's password protected. So you would ideally come up with a good passphrase for that. Once you've done that, you can use that key for any remote machine. So you just need one key pair to get access to all sorts of different machines, as long as you share the same public key with the system administrator there. Okay, so we save the private part of that key. We save it on the, in this case, on the desktop, somewhere where we can easily find it back. And the private key we put on a remote machine. So either send this part to your system administrator, or do it yourself. In this case, I already have a PuTTY session open, so I will add it myself to the authorized keys, which you can find in .ssh, your home directory. So at the end of that file, enter this new public key and save that file. Then we need to establish an SSH connection using PuTTY agent, pagent tool here. So if we double click that, at first sight nothing happens, but here you see a little icon in your taskbar, and if we right click that, then we can add a key, and we add our newly generated ADF key here. We prompt it for a passphrase, and you only need to do that once per login session. So once you've established a working SSH connection via pagent, then you don't need to do that anymore. So once you restart your machine, you would need to fire up pagent again, add the key, enter your passphrase, and then you're done for the remainder of that Windows session. Now in Windows, there's typically one step that we advise to do, is that we'll make sure that this SSH connection actually works. For that we use the command line. So go to the command prompt in Windows, go to your ADF installation directory, and in there go to PuTTY, and there we type in plink, your username, at the remote machine that you want the SSH connection with. And here we see now we've established a connection. I didn't get prompted for my password, and that's because the SSH connection takes care of that for you. So the SSH key pair essentially replaces the normal login that you would have with a username and password. Okay, so we can exit from here, and now we can start setting up this remote queue in ADFJobs. Okay, so we open up ADFJobs, and of course we create a nice little input file that we want to run on the remote machine. And let's search for aspirin. Acetyl salicylic acid, there we go. And maybe we want to run a geometry optimization using a nice functional and double zeta base set with polymerization functions. So we save that job, save it as aspirin, And now we can see that appearing here in our ADFJobs windows. We need to define this new queue that we want to run this job on, and there's various options here for the scheduler. This particular machine will use an SGE, SunGrid engine-based scheduler, but you can use the other templates or talk to your system administrator if you're not sure what to do. Okay, so let's call this queue ADF queue. The option field I'll talk about later. The remote host name, that's the name of your cluster, and that's your login name. And then you can choose where you want the jobs to end up on the remote machine. Home/jobs would be fine, and in that directory then you would find subdirectories that correspond to the directories on your local machine where you run them from. And then the run command, of course, that's the most important part. So qsub is for SGE, and then typically you need a few flags. In this case, let me see. In this case, we want to have a number of nodes that we can choose before we submit, and on that number of nodes we have 16 cores. And the final part of your submission should be $job, because that's what ADFJobs uses for defining the job file that gets submitted to the remote cluster. Now this option, this $options here, that corresponds to this default option. So if I now were to use this particular queue and don't change anything before submission, I would submit to 2 nodes with 16 cores each. Now that's a bit too much for typical kind of small jobs that I run, so I want to have 1 by default. But if I have a particular bigger job, then I can assign it to this particular queue, and if I have a bigger job, then I can say, okay, this particular job needs to run on 4 of those nodes, so on 64 cores. In this case, we'll stick to just the 1. Of course, you can define different queues. Sometimes on the queue, you also need to specify wall time. We have a friendly scheduler that doesn't mind so much how long you run. But then you can think about having, for instance, different queues where you can change the default option, where you can have different wall times. So you can also have this $option field referring to something else. You can change it here before you submit. All right, now let's see what happens when we run this. It transfers the files to that remote machine. It's queuing, now it's running on the remote machine, and you can see it actually picks up the results from the log file while the job is running. All the other bigger files, they're kept on the remote machine until the job is finished. When the job is finished, then it picks up the results from that remote machine, transfers it to your local machine so you can then visualize, for instance, orbital level diagrams, density of states, and other properties. Since from the log file we can also see how geometry optimization progresses, we can even watch a little movie of that. So we can plot the energy of that guy versus geometry step. We can plot the gradient. We can see that's nicely coming down, so that shouldn't take too long. While we're at it, we can also show that, for instance, you can plot distances. You can see that's plotted on a different graph. You can plot things like dihedral angles. And you can see this movie is appended to whenever there's a new geometry available. It will be picked up and it will be added to the movie. Now it's finished, and the graphical interface asks us if we want to update the geometry and the ADF input, which is always a good idea in case we would want to run, for instance, a frequency job or a TDDFT job for UV-Vis. Right, so that's the updated geometry. And now we can see that, okay, locally we also have the tape21 file, but we don't have the full output file, and we don't have all the intermittent tape21 files from the fragments. In case you wanted those, then you could pick them up by saying job transfer from remote, and it will then pick up the results from that remote cluster. If you don't want the results anymore on that remote cluster, just delete them. So you can say job delete remote, and then it would delete all the files that are in the remote cluster. Okay, so that concludes this little demonstration. I hope you find it of good use for using ADFJobs as a very easy tool for setting up your jobs locally, but running them on a remote cluster. And then you can visualize all the results back on your own machine. So that makes life much easier because, for instance, visualizing molecular orbitals, level diagrams is much faster locally than it would be on a remote machine. Alright, if you do have any questions, just let us know at support@scm.com.